Welcome to the second of our nanoBoards promotional videos. My name is Alexander, and in this video I will provide more information on each of our products we developed to help you and everyone else learn analog electronics and PCB design. The nanoBoards, of course. In case you're not really sure what am I talking about, please take a moment to go back and watch the first video we released. It's less than 3 minutes and it will help you greatly as it provides the context of our story today. The link is available in the description of this video and it precedes this particular video in our playlist. So go ahead, click there. Before we move on, I'd like to take a moment and express sincerest gratitude and deepest appreciation for all our patrons that have financially supported the nanoBoards campaign at patreon.com/nanoLuka. Special thanks goes to our Iron Battalion members. Thanks, Splintercat.
Let me demonstrate characteristics common to all of the nanoboards first. As we promised in our introductory video, they are all breadboard compatible in the following way. Using these pins, they are connected to both supply voltage or voltages, as we will see in one of the examples later on, and ground. To connect, just press very gently to the breadboard. Once it is nicely tucked in, let's see what else do they have in common. They all feature pins dedicated to the signal generator and oscilloscope probes. This way, it is very easy to provide the input signal, but also to observe both input and output signals. Finally, the nice little feature are jumpers, which are not present on every one of the nanoboards, but wherever they are, they serve to either break the circuit and enable current measurement, or to provide a change in topology, as we will see in a minute. This first of our modules implements the basic circuit to amplify signals, as in increase its intensity, make it louder, if we go back to our sound example from the first video. This PCB features common emitter and cascode topology, easily transforming from one to another by way of changing jumper positions. This is a great way to demonstrate the trade-off between complexity, performance, and power consumption. The second device introduces us to the frequency characteristic, which is an extremely important tool to both analyze the circuit's behavior over a set of frequencies and design circuits that perform accordingly over a specific bandwidth, both of which are engineering tasks that we come upon on a daily basis. One of the omnipresent and most surprising concepts in the analog electronics and many other engineering fields is feedback, demonstrated using the next module. By way of returning a part of output signal to the input, we can achieve better stability, temperature, and frequency performance. We can select the intensity of feedback by setting the feature potentiometer to the appropriate value. Circuits that feature an output without any input provided are classified as oscillators. This is another major chapter that we cover with our fourth module, which generates a continuous, repeated, alternating waveform required to broadcast radio or TV signals and regulate operation of computers. This is the case where we use dual rail voltage supply.
In this video, we showed features common to all of the nanoboards, and then we took a closer look to each one of them. In the next videos, we will explain how to use them by demonstrating their operation. Kindly consider joining our community and thus helping us further develop open source hardware and bring analog electronics engineering field closer to everyone. Thanks for watching, follow us, and please subscribe not to miss any of our future releases.